Hello everyone, this is Sahitya, working as assistant professor in EC department, MLR Institute of Technology, Hyderabad. Now I have to discuss about the electronic devices and applications. In that electronic and device applications, now in the today's session we have to go about the rectifiers. Here the rectifiers are nothing but the applications of the PN junction diode. So we have so many applications for the PN junction diode. Some of the applications are, so it is used as a rectifiers, clippers, clampers, filters, and next the main application for the PN junction diode is nothing but the switch. So today we are discuss about the rectifiers. Coming to the today's sessions, in the today's session the overview of that session is we have to discuss about the definition of what is the definition of the rectifiers, and also we have to discuss about the types of rectifiers. In the types of rectifiers we have to discuss about the half-wave rectifier, construction of the half-wave rectifier, operation on the working principle of the half-wave rectifier, and next another type of the rectifier is nothing but the full-wave rectifier. In that full-wave rectifier we are discuss about the with center tapped rectifier and without center tapped rectifier. This is about the today's content. Next, what is the definition? So what is the definition of the rectifier? So rectifier is a which device? Rectifier is nothing but the semiconductor device. Why it is a semiconductor device means here the rectifier uses the rectifier is constructed by using the PN junction diode. So the PN junction diode is nothing but the semiconductor device. So here the rectifier is a semiconductor device. So it converts the alternating current into direct current. Why we have to convert the alternating current into direct current? So in the alternating current it contains both positive half cycle and negative half cycle. So here during the positive half cycle the device will be charges. During the positive half cycle, the device is charges, and during the negative half cycle, the device will be discharges. So when it will be discharges, what is happening? There is no charge in that device. Nowadays, we are using the battery devices. For the operation of the batteries, it uses the continuous DC current. So it requires only the positive half cycle. So it uses only the positive half cycle. So for the positive half cycle, the half-wave rectifier will be charges. So for this purpose we are going for the rectifiers, and here the rectifiers will convert the AC to DC, which allows the current only in one direction. And next, here we have to discuss about the types of rectifiers. So the rectifiers are classified into two types. They are full-wave rectifier and half-wave rectifier. Full-wave rectifier and half-wave rectifier. So first we have to discuss about the half-wave rectifier. What is meant by half-wave rectifier? So half-wave rectifier is a rectifier which rectifies only one half cycle. That rectifier is called as a half-wave rectifier which rectifies only one half cycle, that is either positive half cycle or negative half cycle. Half-wave rectifier is a device which rectifies either positive half cycle or negative half cycle. So it will rectifies only the one half cycle. So here the efficiency is very low. Next, coming to the full-wave rectifier. In the full-wave rectifier, it rectifies both positive half cycle. This is nothing but the input signal to the rectifier. Coming to the output of the full-wave rectifier, it rectifies both positive half cycle, that is either in positive direction or in negative direction. So it will be depends upon the construction. So it will rectifies both positive half cycle and negative half cycle. Whereas in the half-wave rectifier, we are using only the one diode. By using only one diode, we can constructing the half-wave rectifier. Whereas coming to the full-wave rectifier, we are using the two diodes. We are using the two diodes. And the last one is bridge rectifier. So bridge rectifier is nothing but the full-wave is also comes under the full-wave rectifier. Same the operation of full-wave rectifier, it will also rectifies both positive half cycle and negative half cycle. So it rectifies either in positive direction or in negative direction. For the bridge rectifier, we are using four diodes. We are using the four diodes. This is about the types of rectifiers. So rectifiers are classified into three types. What are the three types? Half-wave rectifier which rectifies only one half cycle, whereas full-wave rectifiers and bridge rectifier will rectifies both cycles, that is in either in positive direction or in negative direction. Next, the first one is half-wave rectifier. In the previous slide, we already discussed the half-wave rectifier is constructed by using a single diode that will be conducted during only one half cycle, that is either positive half cycle or negative half cycle. When it will be conducted only one half cycle, then the efficiency will also be decreases. Coming to the design, here we are using only the one diode, then the design will become simple. Coming to the construction of the half-wave rectifier, it requires transformer, diode, load resistance and filter. So first we have to discuss about the transformer. So here the transformer is actually classified into three types. The three types are, what are the three types of the transformer we know? Step up transformer, step down transformer and mutual transformer. So what is meant by the transformer? Transformer is used to transform the energy from primary winding to the secondary winding. Whereas coming to the step-up transformer, in the step-up transformer, the number of windings in the primary winding is less than the secondary winding. So here the voltage will be increases, the output voltage will be increases. Whereas coming to the step-down transformer, in the step-down transformer, the number of windings in the primary winding is more than secondary winding, then the output will get the less voltage. Whereas coming to the mutual transformer, in the mutual transformer, the windings in the primary winding and the number of windings in the secondary winding are equal. So what we give the input voltage, the same output voltage will also be occur. So coming to the transformer, the transformer is works on the principle of EMF, electronic magnetic force. So it contains two windings. What are the two windings? Primary winding and secondary winding. So this is nothing but the primary winding. The primary winding is nothing but N1 and the secondary winding is nothing but N2. So if N1 is greater than N2, then the type of transformer is called as step down transformer. If N1 is less than N2, then the type of transformer is called as step up transformer. If both are equal, N1 is equal to N2, then the type of the transformer is called as a mutual transformer. So here the mutual transformer, we are taking the step down transformer. Why we are taking the step down transformer means we have to reduce the output voltage. For example, if you consider the household applications, for the household applications, what is the voltage? 230 volts. 230 volts, 50 Hz. This input is given to the transformer. So AC voltage means, what is meant by AC voltage? It contains both amplitude and frequency. 50 Hz is nothing but the frequency. So this is nothing but the input. So here now we are using which transformer? Step down transformer. So in the step down transformer, the number of windings will be decreases and the output of the secondary winding is connected to the PN junction diode. The output is connected to the PN junction diode. So here we are using, in the half-wave rectifier, we are using only single diode. So here this terminal, anode terminal is connected to the secondary winding and the cathode terminal is connected to the load resistance. So here the output of the rectifier is not a pure DC. For getting the pure DC, we have to connect it to the either inductive filter or capacitive filter. So here filter. So what is meant by filter? Filter is used to remove the unwanted frequency components or which is used to remove the unwanted ripples. And produce the smooth DC value. So that is the purpose of filters. So here this is the construction of the half-wave rectifier. So for the half-wave rectifier, it requires one transformer, which is we are using the step down transformer. And now the next one is the next device is the PN junction diode. So here we are using only the single PN junction diode. So which is used to generate only, or which is used to rectifies only one half cycle, and the output is connected to the load resistance. And here the rectifier will not produce us the pure DC. For getting the pure DC, we have to connect the output of the rectifier is connected to the filter. So filter purpose is which is used to remove the unwanted frequency components, or which is used to remove the ripples and produce the pure DC value. Next, coming to the operation. In the last slide, we are see about the construction. So coming to the construction, what is the construction? Here we are using the transformer. The transformer is nothing but the step down transformer, and the output of the step down transformer is connected to the PN junction diode. So here the output of the secondary winding, is connected to the anode terminal, and cathode is connected to the load resistance. So what is the input for the transformer? We are giving AC signal. So here for the AC signal, it contains both positive half cycle and negative half cycle. So the operation can be operated in two modes. So the operation is operated in the two modes are positive half cycle and negative half cycle. So it will be operated in how many modes? Two modes. So what are the two modes? Positive half cycle mode and negative half cycle mode. So now first see down what is happening for the positive half cycle. So if you give the positive half cycle, so positive half cycle means the input voltage, the upper winding of the transformer will becomes positive and the lower one will becomes the negative. The same voltage will be transformed to the secondary winding, positive voltage and negative voltage. Now see here, the secondary winding of the transformer is connected to the p-type semiconductor, that is nothing but anode. The positive is connected to the p-type semiconductor, means then the diode is connected in which bias? Forward bias. When the diode is connected in forward bias, then it acts as closed circuit. When the circuit will becomes closed, then the current will be flows. In that circuit. So here the circuit will becomes closed circuit. So in the closed circuit, what we give the input? The same output will be generated. What we give the input? Positive half cycle. So the output is nothing but the positive half cycle. So this is done during the positive half cycle. And what is the second mode? The second mode is nothing but the negative half cycle. So what is happening for the negative half cycle? So for the negative half cycle, what is the input we are giving? Negative input. What are we giving the input? Then these terminal will becomes negative and these terminal will becomes positive. That terminal will becomes negative and that terminal will become, this terminal will becomes positive. The same voltage will be transmitted to the secondary winding. So here this voltage will becomes the negative and this voltage will becomes positive. Now see here what is happening. Here the negative terminal is connected to the p-type semiconductor. When negative terminal is connected to the p-type semiconductor, then this diode will goes into the reverse bias. When it is operated in reverse bias, what is happening? In the reverse bias, the diode will becomes open circuit. So here when the diode is open, then the circuit will becomes open circuit. Then there is no current flow. When there is no current flow, then the output is equal to 0 volts. Then the output is equal to 0 volts. So now see, for if you apply the both positive half cycle and negative half cycle. So what is happening during the positive half cycle? During the positive half cycle, the diode is in on state. The diode is in on state. During the diode is in on state, then the circuit will becomes closed circuit. When the circuit is closed circuit, then output is equal to input. Next, during the negative half cycle, the diode will becomes open circuit. The diode will becomes open circuit. When the diode is open circuit, then output is equal to 0. Next, again we are getting positive half cycle, and again during the positive half cycle, output is equal to input, and for the negative half cycle, output is equal to 0. And next, for the again positive half cycle, output is equal to input. So that's why it is called as a half-wave rectifier. Why it is called as a half-wave rectifier means here the rectifier will rectifies only positive half cycle. Will rectifies only the positive half cycle. So here the efficiency will be reduced. Why? Because means out of 100%, only the output we are getting the 50%. That's why the efficiency will be decreases. Next, if you want to, here what is the output voltage we are getting? Only the positive voltage. If we require only the negative half cycle, if we require only the negative half cycle means, then the diode is connected in reverse. Means the cathode is connected to the secondary winding and anode is connected to the load resistance. Now see what is happening. Let us consider this terminal is A and this terminal is B. And this terminal is C and this terminal is D. What is the input voltage? The input voltage is nothing but the AC. So AC means it contains both positive half cycle and negative half cycle. So first we have to see the positive half cycle. What is meant by positive half cycle? Which gives only the positive voltages. Then the node A will becomes positive, node B will becomes negative. Then the same voltage will be transmitted to the node terminal C and terminal D. So the terminal C will becomes positive and the terminal D will becomes negative. Now the positive is connected to the N-type semiconductor. Positive is connected to the N-type semiconductor. When positive terminal is connected to the cathode terminal, then the diode is operated in which bias? Reverse bias. So during the reverse bias, the diode will becomes off state. So in the off state, the circuit will becomes open circuit. So during the positive half cycle, when the circuit is in open circuit, then output is equal to 0. So during the positive half cycle, there is no output. Next, during the negative half cycle, the node A will becomes negative and the node B will becomes positive. The same voltage is transmitted to the terminal C and terminal D. So what is the voltage across the terminal C? Negative voltage. And what is the voltage across the terminal D? Positive voltage. Now see what is happening here. The diode is connected in reverse bias. Now the negative terminal is connected to the negative terminal of the diode. Means the diode is connected in which bias? Forward bias. The diode is connected in forward bias. So what is happening in the forward bias? In the forward bias, the diode will becomes on state. So on state means the circuit will becomes closed circuit. When the circuit will becomes closed circuit, then the current will be flows. When there is a current flow in the circuit, then output is equal to input. What is the input here? Negative half cycle. So during the negative half cycle, the diode is in conduction state, and during the positive half cycle, the diode is in off state. So it rectifies only the negative half cycle. So this is the output of the half-wave rectifier. Here also it rectifies only the negative half cycle. So rectifier, the half-wave rectifier means which is used to rectifies only one half cycle, that is either positive half cycle or negative half cycle. This is about the half-wave rectifier. And the next, Second one is full wave rectifier. So we already see the disadvantage of the half wave rectifier. So half wave rectifier means which rectifies only one half cycle. So when it rectifies only one half cycle, then the efficiency will also be decreases. When the efficiency is decreases, then it will not be applicable for the so many devices. So that's why we have to come for the full wave rectifier. In the full wave rectifier, it rectifies both positive half cycle and negative half cycle. So here the full wave rectifier can be constructed in two modes. The first one is full wave rectifier with center tapped and full wave rectifier without center tapped. So first we have to discuss about the full wave rectifier with center tapped transformer. So full wave rectifier with center tapped transformer means, so here we are using the two diodes. So let's see the circuit diagram for the full wave rectifier. So same as half wave rectifier, it also consists of transformer. So here also we take only the step down transformer. So in the step down transformer, the number of windings in the primary winding is greater than secondary winding. And in the full wave rectifier, we are considering the two diodes. So one diode is connected to the one terminal of the secondary winding, and another diode is connected to the another terminal of the secondary winding. So here the two diodes are connected to the two ends of the secondary winding, and here the secondary winding is center tapped. The secondary winding is the center tapped. So center tapped means the secondary winding is equally distributed. And the output of the two diodes is connected to the load resistance. This is the diode D1 and this one is the diode D2. What is the input for the rectifier? AC signal. Same as half wave rectifier. Here also the full wave rectifier is operated in two modes. The two modes are positive half cycle it is also operated in two modes, positive half cycle and negative half cycle. So it is also operated in two modes, same as half wave rectifier. So first see about the positive half cycle. So what is happening for the positive half cycle? So here what is the input? We are giving only the positive input. So for the positive half cycle, what is the voltage sources? We are getting positive voltages. Then here let us consider it as a node A and let us consider it as node B, and this one is the node C, D, E. A, B, C, D, E. So now when we are applying the positive voltage, then the node A will becomes positive and the node B will becomes negative. When the node A is positive, the same voltage source will be transmitted to the node C and the node D will becomes negative. Similarly, here the positive voltage is connected to the node D and the negative voltage is connected to the node E. So here what is happening for the this circuit during the positive half cycle? So during the positive half cycle, C will becomes positive. When C is positive, then the diode is connected in the forward bias. Why? Here the P-type semiconductor is connected to the positive terminal. P-type semiconductor is connected to the positive terminal. Then the diode D1 is operated in which bias? Then the diode D1 is operated in forward bias. So in the forward bias, we already know the diode is in which state? On state. So in the on state means then the circuit will becomes closed circuit. Next, similarly, when it comes to the diode D2, in the diode D2, the P-type semiconductor or anode terminal is connected to the negative terminal of the battery. When anode is connected to the negative terminal of the battery, then the diode D2 will goes into which bias? Reverse bias. So what is happening in reverse bias? The diode will goes into off state. So in the off state, the diode will becomes open circuit. When it is open circuit, there is no current flow. Now see, the current will be transmitted in this upper loop only. So coming to the current direction, how the current will be flows from the C2 diode D1 to the load resistance RL, and the diode load resistance RL to D, terminal D, and the terminal D to C. So this is the path. So what is the output? When the circuit will becomes closed circuit, then output is equal to input. So what is the output? Positive half cycle. So this is for the positive half cycle. And next, what is the next mode? Negative half cycle. So what is happening for the negative half cycle? For the negative half cycle, we are giving the negative voltages. We are giving the negative voltages. When we giving the negative voltages, negative half cycle, the voltage will becomes the negative voltage. Then the node A will becomes negative and the node B will becomes positive. So then the voltage across the terminal C will becomes negative and the terminal D will becomes positive. So here this terminal will becomes negative and this terminal will becomes positive. Now see what is happening. When we apply the negative voltage, here the node C will becomes negative. When the negative terminal of the battery is connected to the anode terminal, then the diode D1 will becomes, then the diode D1 is operated in which bias? Reverse bias. So what is happening in reverse bias? In the reverse bias, the diode goes into the off state. In the off state, that will becomes open circuit. So the diode D1 is operated in the reverse bias. Next, similarly, when come to the diode D2, here E will becomes positive. E will becomes positive. When E is positive, then it is connected to the positive terminal of the diode. When both are in same, then the diode D2 is operated in which bias? Forward bias. So what is happening in forward bias? In forward bias, the diode is in on state. The diode is in the on state. So in the on state, the circuit will becomes the closed circuit. So the circuit will becomes the closed circuit. Now see what is the path here. So coming to here path, so the current will be flows from E. The current will be flows from the E to diode D2 and diode D2 to load resistance RL, and the load resistance RL to the terminal D and D to E. This is the path. So here the circuit will becomes closed circuit and here the voltage will also becomes reverse. So if you apply the positive half cycle, then there is a phase shift of 180 degrees phase shift. So what is that voltage? If you apply the negative half cycle, the cycle will becomes, the output will becomes the positive half cycle. So what is the output of the full wave rectifier with center tapped? It rectifies both positive half cycle and negative half cycle. So here the efficiency will be increases. So by using the two diodes we can construct it, and here we are using the center tap transformer. Okay, this is about the full wave rectifier with center tap. And the last one in the rectifier is bridge rectifier. So here the bridge rectifier can be constructed by using the 4 diodes, and here the transformer is not a center tap transformer. So here we are using the 4 diodes. For the half wave rectifier we are using 1 diode, and for the full wave rectifier we are using the 2 diodes, and for the bridge rectifiers we are using the 4 diodes. Same as half wave rectifier. Here we are using the transformer. The same transformer will be used. What is the transformer we are using? Step down transformer. Step down transformer means, what is meant by step down transformer? The number of windings in the secondary winding is less than the primary winding, and in the bridge rectifier we are using the 4 diodes. So what is the input for the bridge rectifier? AC input. So let us consider it as a node A, node B, node C and node D. Here we are using the 4 diodes. Diode D1, diode D2, diode D3 and diode D4. So here all these diodes are arranged in the form of bridge. So that's why it is called as a bridge rectifier. Why it is called as bridge rectifier means here the diodes are arranged in the form of bridge. So that's why it is called as a bridge rectifier, and it uses the 4 diodes and it rectifies both half cycles. So it rectifies both positive half cycle and negative half cycle. Same as the half wave rectifier, here also the rectifier will be operated in positive half cycle and negative half cycle. So first we have to see about the positive half cycle. So positive half cycle means what is the voltage sources we are giving? Positive voltages. When we are giving the positive voltages, the node A will becomes positive and the node B will becomes negative. So similarly the node C will becomes positive and the node D will becomes negative. So when the node C will becomes positive, this point will becomes positive and this point will becomes negative. This point will becomes negative. Okay, when at this terminal we are connecting the 2 diodes. What are the 2 diodes? Diode D1 and diode D4. Diode D1 and diode D4. So what is happening for the diode D1? Here the diode D1 is connected in forward bias. Diode D1 is connected in forward bias. Diode D1 is connected in the forward bias and diode D4. The diode D4 is connected in reverse bias. Why? Because the positive terminal is connected to the negative terminal of the diode. Then the diode D4 is connected in reverse bias. So in the reverse bias, it is in off state and in the forward bias, it is in on state. Next, coming to this node, at this node, the voltage will becomes negative. When the voltage is negative, then the diode D2 is connected in reverse bias. The diode D2 is connected in reverse bias. So when diode D2 is connected in reverse bias, what is happening here? When the diode D2 is in reverse bias, then it is in off state. Why it is reverse bias? Because the negative terminal is connected to the positive terminal of the battery. So that's why the diode will becomes reverse bias. Next, come to the diode D3. For the diode D3, the negative terminal is connected to the negative terminal. So then the diode is in which bias? Forward bias. So during the forward bias, the diode is in on state. So which diodes are in on state? Diode D1 and D3. So what are the D1? D1 is in on state and D3 is in on state. D1 and D3 is in on state, where D2 and D4 is in off state. When it is in off state, then the circuit will becomes off. Okay. Now see what is the current flow here. The current flow will be flows from C terminal to terminal C to diode D1 and diode D1 to load resistance RL and the load resistance RL to this node point. Let us consider it is a node F and this node is a G. F and F to D3, again D3 to D and D3 to D. Here the circuit will becomes closed circuit. When circuit will becomes closed circuit, then there is a current flow in that circuit. When there is a current flow, then output is equal to input. What is the input? Positive half cycle. So when there is a positive half cycle as a input, the output is also same. Next, what is the next mode? Negative half cycle. So negative half cycle means we are applying which voltages? So negative voltages means then the node A will becomes negative and the node B will becomes positive. So then the C will becomes negative and D will becomes negative. When C will becomes negative and this node will becomes negative, this node will becomes positive. So when this node is positive, then the diode D1 will goes into here. The negative terminal is connected to the positive terminal of the battery. When negative terminal is connected to the positive terminal of the battery, then the diode is operated in reverse bias. So in the reverse bias, the diode is in which state? Off state. Next, at the same time, the negative voltage is applied to the negative terminal of the battery. When the negative voltage is applied to the negative terminal of the battery, then the diode, this diode is nothing but the diode D4. Then the diode D4 is operated in the forward bias. In the forward bias, it is in which state? On state. Next, here, what is the voltage source we are applying? Positive voltage. So, during the positive voltage, the diode D2 will becomes forward bias. Why? Because the positive terminal is connected to the positive terminal of the diode. Then the diode will becomes forward bias. In the forward bias, it is in on state. And for the diode D3, but the positive is connected to the negative terminal. So diode D3 will enters into the reverse bias. In the reverse bias, it is in off state. So it is in open. So now what are the diodes is in forward bias? D4 and D2. So D4 and D2 will becomes closed. D4 and D2 will becomes closed circuit. And D1 and D3 are enter into the reverse bias. So during the reverse bias, it will becomes open. So what is the current flow here? During the reverse bias, what is the current flow? The current will be flows from C to D4, D4 to F, F to load resistance to G, G to diode D2, diode D2 D. So here the output is 180 degrees phase shift. So if you apply the negative half cycle, the output will becomes positive half cycle. So it rectifies both positive half cycle and negative half cycle. So here the efficiency will also be increases. This is about the rectifiers. So in the next session, we have to discuss about the parameters. So the parameters are nothing but we have to discuss about the DC value, average DC or average value, RMS value, ripple factor, efficiency, transformer utilization factors. All these will be discussed in the next session. And we have to write the comparison between the half wave rectifier, full wave rectifier and bridge rectifier. Thank you.